In this video we're going to be taking an introductory look at GMoor 10 from the point of view of a new user, but also that of someone who is used to using GMoor 9 and wants to investigate the new features of GMoor 10. The file I'm going to be working with is dyn example, and once you've installed GMoor you'll find this under Documents and then GMoor 10 example files, and it's this file here, dyn_example.gmrdb. So having opened that file up in GMoor 10, this is how the interface looks, and we're going to start off working in what we call the interactive mode, where we can make changes to the settings, to the spread and to the environment, and we can see those reflected in the visual representation of the field and also in the results for line tensions, vessel position, motions and forcing. So this in the top left is the field view. I can pan around by dragging with the mouse, just by clicking on the background and holding the mouse. I can zoom in or out with the scroll wheel. There's a button here in the bottom right to auto fit, so I can click on that to zoom in or out to fit the entire spread to the window. If I'm perhaps on a laptop and I don't have a scroll wheel, I've got an option here to pan with a specific control, and likewise to zoom with a rectangle, so that could be particularly useful if you're working on a laptop. And you'll notice that as I move around with my mouse, there are certain elements in the field that will highlight as the cursor is positioned over them, and I can click any of these elements to open up a context-specific menu of common options relating to that particular element. So for example, having clicked on a mooring line here, I have an option to fail that line, and if I click on that, we'll immediately see the effects of that line failure. I've now got a button in the interactive part of the ribbon up here to undo previous, and we can remember up to the last 20 changes made, and we can go step by step and reverse those. So having failed that line, I can click undo previous and we've restored the line. So to go around the remainder of the tabs, line results will give us line tensions from the quasi-static and dynamic analyses. Vessel position will give us the mean vessel position and offsets from the target position, as well as the anchor positions. If we have thrusters applied, we can see the allocation of the thrusters in this tab here. Going to the top right now, Motions tab will give us the wave and low frequency motions, as well as damping and stiffness as calculated within the quasi-static analysis. And the Forces tab will show us the forcing from each of the environmental inputs. And in the bottom right here, we have a 3D representation of the vessel and the mooring lines. So the first thing we're going to look at is the analysis settings, which is the first button in this interactive ribbon up here. So if I click on that, so here is where we have options first of all to set up any details that we might want to show in an eventual report, so a description of the analysis. If we've got a client and a project, we can enter those details to appear on the report. We have controls here to enable calculation of second order, so low frequency motions. If we want to, GMoor also has a time domain mode, providing you have the full version of GMoor, so we can also activate that if we wish, and then it will run a time domain simulation for calculation of those second order motions. We can activate line dynamics, again depending on which version of GMoor you've got. If you are running line dynamics, this is where you can specify the code to which you're working, and if you need to make changes to the safety factors, you can also review and modify the safety factors below. Under damping, we can apply additional damping to our analysis, as well as enabling options for both wave drift and mooring line damping. Under wave drift correction, we can activate the wave drift correction formula that is provided by DNV in DNV-GL OS E301. Under extra force and motion, we can apply additional force and additional motion if we need to under a particular axis. And finally, if we want to do sort of a transient analysis interactively, we can simulate any particular failure case. So the options you'll see in this list will depend exactly on your configuration of spread, so the number of lines you've got and whether you have buoys, whether you've got thrusters, and so we can click on one of those to then sort of see the effects of that transient analysis. So we can see there, if we zoom in, sort of the different steps that the vessel takes within that transient time domain. If I come into environment, this is where we can set up all of our environmental inputs. So we have tabs here for wind, for wave, for current, including options for wind-induced current. And if we want to apply the wind and sea by setting a Beaufort force, we can also do that as well. And we can input our direction. And in the bottom right hand corner, you've got little indicators down here which will show you the currently applied wind current, sea and swell. And I can also click on one of the options for sea or swell to see exactly what spectrum is being applied. So those are the options for providing sort of the inputs to the analysis in terms of settings and the environment we want to apply. The other side of the equation, of course, is the actual makeup of the spread itself. So we have two buttons here on the right under the spread part of the ribbon which affect the configuration of the spread. So if I press edit vessel, here we can give a name to the vessel, a description of the vessel that we're currently working on. Within GMoor we require a CVF file, which is a GMoor specific file that either we can create for you within Global Maritime, or there is a program called Make CVF that comes with GMoor that you can use to create that yourself. And then here is where we can pick our field file, which is just the sort of the background image we display. So in this case we've got a GMoor specific FLD file, but we can also make use of an AutoCAD DWG. We also set up properties such as water depth and reference and target positions. If we have a gangway, we've also got a tab here where we can specify the gangway landing points on both vessel and platform. If I click on Edit Lines, here we have two tabs. So within GMoor we can define a number of line types. So each line type consists of one or more components. Within any given line type, one component is designated as the adjustable component, and where the payout is changed, it is the length of that adjustable component that we modify. So at all times the total payout that you're using within GMoor must lie within the range allowed by that adjustable component. So it must be at least the sum of the lengths of the non-adjustable components, and then without exceeding the total sum of all of the component lengths including the adjustable. Under line deployments we then indicate for each fair lead number what line type we want to deploy from that particular fair lead. We can deploy in different ways, so we can deploy using a payout and a pretension. We can deploy using a payout and a range, or a pretension and a range. So bearing in mind when we talk about a pretension, this is a pretension on an individual catenary line, and the final tension at equilibrium might be different, particularly with an asymmetric spread. Switching back to the line types then, we can see that for each of the components we have a little sort of diagrammatic representation of that on the right hand side. I can click on those components, which then highlights it red, and I'm then able to edit the properties for that component. So there are two parts to the component properties. We've got properties on the left here which are compulsory within GMoor, and on the right hand side here we've got dynamic properties that are only relevant if you're running line dynamics on the analysis. If we have, for example here we've got an anchor, or I can perhaps insert a buoy here. If we have a connector that is a weight or a buoy, we get additional properties that are required to be filled out for that particular connector. And again, if I was to put a buoy in here, for example, we'll see a graphical representation of that on our little diagram on the right hand side here. There are two solution schemes within GMoor. One is what's called theta solve, which is the original solution scheme in GMoor 9, and the new default within GMoor 10 is intermediate grounding, and as the name would suggest, that solution will cope with intermediate grounding between a buoy and the fair lead. So in order to create a situation perhaps where we can demonstrate the use of this, we're going to zoom out a little bit, and we're going to produce a catenary plot on line 1, which I'm going to position down here. And just to simplify things, I'm going to zero the environment so that we only have one tension plotted. So let's say, for example, that within this catenary line, line 1, we need to provide clearance at about 1,000 meters from the anchor because we've got a pipeline on the seabed. I can come into my edit lines here, and if I look at my line deployments, we can see that line 1 is represented by line type 1. But that same line type is also applied on fair leads 4, 5 and 8. So if at the moment I was to add a buoy to line type 1, it would affect not just line 1 but also those other 3 lines as well. We've got a button in the bottom here, flatten line types, which is designated to create a new line type for each line. So if I press that, we'll see now that each of these lines has its own unique line type. So it's effectively duplicated line type 1 and created 3 additional copies of it so that each of these lines has got its own unique example of the line type. So I can now go back to line 1. I can highlight this long adjustable component, which is the one that's closest to the fair lead, represented by our F here, and anchor is in the top here. And I can press split. So by default that has split that component into 2 sections of equal length. So we've got one here of 2,500 meters and another one here of 2,500 meters. So that's obviously far too long for our purposes here, so I'm going to change that to 500, and then that will give us not quite but roughly the 1,000 meters of range we want from the anchor. And then for our purposes here 2,500 meters on the adjustable component is fine. I don't need to change that. And you can see that with this component selected, that's also selected here the connector between that component and the other. So that is where I can then create my buoy. So let's say we're going to create 15 tons of buoyancy, give it a pennant length, and then as soon as I press OK there, you can see now that roughly at 1,000 meters we've just introduced that buoy and we've now got a bit of clearance from the seabed. So within GMoor, everything that we do is now saved within a database file, and this will be something that's new to people who are familiar with GMoor 9, where previously we had a spread file which was a text file and it was only the results that were stored in a database. Well, now everything you do is stored in the database, and it's important to get into the habit of saving that database, because if you don't, you're not going to keep the changes that you've made. So I can do that by going File, Save, or if I wanted to give it a new name because I'm working on it and I want to not overwrite the original, I can use Save As and then give it a different file name. Now, because we're putting all of the inputs into GMoor, when we save data to the database by writing results, which is what we're going to do in a second, when we write results, we'll store the results of that analysis, so in this case the particular interactive analysis we're currently working on, but we'll also save along with that all of the associated inputs. So that's the environment, it's the settings, but it's also the configuration we've made to the spread, in this case also including the modification we've just made to the buoy. So what I'm going to do now is I'm just going to go and give my spread here a different title. So we're going to call this Test Case 15-ton buoy. And if I come up here to write results, there are 2 ways in which you can create results within GMoor. One is when you're working interactively, and then you would click the Write Results button and then you would specifically say, I want to preserve what I've just produced. And the other way is by running batch cases, and we'll look at batch cases very shortly. So for now, we're just going to do Write Results here. And if I press now this button, Manage Database, this allows us to view all of the cases we've written to the database. So we can see here now we've got a spread, which is our test case 15-ton buoy, as we just specified a minute ago. We've got our interactive configuration that we're working with, and then we've got the results of that interactive analysis that we just saved a second ago. And in the bottom left, we can see that I can actually group these in different ways. So here I'm grouping them by spread, so that's the sort of highest level of the hierarchy. I can group by configuration. So configuration is a combination of the analysis settings and the environment. So if I group by that way, we get a slightly sort of inverted view. So the configuration first, then the spread, and then the results. Or I can group by run date. So here we can see that there was an interactive run at this date and time, and here is my result. And within this database management window, if I want to delete things, I can just select at any level, so I can delete individual results, or I could select, for example, the spread and press delete selected, and that would then delete all of the data underneath that level. So I'm not going to do that for now. What I'm actually going to do instead is make some further changes to this buoy, just so that I can show you another feature of that Manage Database window. So we're going to come back into Edit Lines. We're going to go back to our buoy, and I'm just going to quickly say 25 tons, and we'll change the name of our spread accordingly, and we'll write results again, and we'll do that one more time. We're going to call this now 35 tons. We're going to set the buoyancy, and I'm going to write results. Okay, so now if I go to manage databases, and you can see here we've got these three separate spreads. Well, we've got three separate spreads, but our inputs for the environment haven't changed. You can see here we've got the same configuration in each case. So I'm going to group it by configuration, and then here this is a much easier to follow hierarchy, because we've got a single configuration on which we've used these three spreads, one with a 15-ton buoy, one with a 25-ton buoy, and one with a 35-ton buoy. And we can see that for each of these we've got some results saved. So one thing we can do in GMoor is we can take any of the results in the database, whether they've been produced interactively or whether they've been produced as part of a batch run. I can highlight the result, and I've got a button at the bottom here that says Make Interactive. So if I'm working through an analysis and I have set up a particular configuration and I think, well, I'm not sure whether this is the one yet, so I'm going to make some further changes, I can save a result interactively. And then if I want to go back and then reproduce those same conditions later on, I can press Make Interactive. And so you can see there we're back to our 15-ton buoy. Similarly, I can come back into this dialog. I can come into, say, the 25-ton buoy and Make Interactive. And so it makes it really easy to sort of save a collection of different models of different simulation inputs, all within the same database file. So we spoke a second ago about being able to delete things from the database, so we're going to do that just now. So if I go to Group by Run Date, you can see that on these three different dates and times we've run interactive analyses. So I can highlight all three of those and press Delete Selected. And then if I go back into Manage Database again now, you'll see that everything's gone. We'll always have something here because this represents the one that we're editing interactively, but you can see at the moment we haven't got any save results underneath this. So the next part of GMoor, as we've discussed, is to run things through a batch. And there are two different ways of doing that, though in fact before I do that I'm just going to reopen my file so I get rid of that buoy that I'd created. So if we go now to the Batch Reporting tab, we've got different batch options, and we're going to start off looking at manual batch, which will be familiar to anybody who's used GMoor 9 in the past. So this works on the basis that we create a series of batch cases where each case has its own unique combination of inputs for environment, for analysis settings, even for the spread. And so you can see here we've got 4 buttons that are equivalent to the same 4 buttons that we have interactively. And if I was to click on any of these, so for example if I go to the environment and apply Beaufort from a direction, we get a little representation underneath, which might be quite difficult to read in the video, but it tells me here my wind speed has been set to 17.7 meters per second, wind direction for 45 degrees, sea height, period and direction. So up to a certain number of properties it will show us specifically how that batch case differs from the existing interactive settings. So it makes it quite easy to see what each batch case is actually going to do. I can make other changes, so for example here I can come in and say, well okay, we're going to call this gale from 45 deg, for example. On the right of those buttons we've got tick boxes where we specify which failure cases we want to run. So by default we've got intact cases enabled, but we can also say we will also want to have single line failure, and perhaps also for those single line failures we want to do the transient analysis also. So I can tick the boxes to specify exactly what I want to run. I could then say, well okay, that's great, I've got gale from 45 degrees, so I could say new from selected. I can come in here and say, well okay, we're going to call this one 90 degrees. Don't need the copy of. We're going to then change our Beaufort accordingly to reflect the new title. And I could carry on like that and gradually build up a series of different directions, and then we can simulate all of those one after the other. Now, because that's such a common occurrence, what we've actually got is an option here that says rotate selected. So this allows us to either rotate the environment every 45 degrees, or we can put in a different interval there, 22.5, etc. Or we can say we want to apply the environment both down and between lines. So if I delete the one I've just created, and we'll give this a title that doesn't refer to the direction because it'll add that for us automatically. I can then say rotate selected, apply down and between lines and create cases, and then you can see there it's then generated those. And if we look down each of these you can see then the directions set accordingly. So we've got 0, 22.5, 45 and so forth. So having created the cases I want, If suddenly I realise I've made a mistake and I've forgotten to set an option, I could, for example, say, well, I want to have dual line failure, so I can come and click each of these individually. But I could also select all of the cases, and then with all of the cases selected, if I toggle these tick boxes, it will affect all of the selected cases. Similarly, if I click on, for example, analysis settings, and I want to add perhaps second order motions. In fact, we've already got second order motion, so we'll add line dynamics. Because I've got multiple cases selected, when I come out of changing those options, it will say, do you want to apply these changes only to the current case, the one I clicked on? Or if you want to, you can also say that you want to copy the changes to each of the other cases that you had selected. So if I say copy just the changes, you can see there now that line dynamics has been applied to each of these, but we've not changed the direction. So the 0 degrees one is still 0 degrees, the 22.5 is still 22.5, and so forth. So once I'm happy with my batch cases, if I wanted to, I could save those to a file and then load them at a later date. But for now, I'm just going to go ahead and run my batch. So that'll go off and run those cases, and we'll get some progress as to how that's going on. And then after a few seconds, and this is all now running multi-threaded as well in GMoor 10, which was not possible in GMoor 9, that's now completed. And if I was to go into our interactive and manage database, we can see there now that for this spread, we've created all of these different configurations. So those are the ones we created using the down and between line tool. And for each of these, we've got the no failure, i.e. the intact case, and then single line failure, both standard and transient for each of the lines. So now that we've got some results in the database, the next thing to look at is reporting. So within GMoor 10, both the batch and the reporting is scriptable, which is a little bit beyond the scope of this video, but you should know that we can create new reports based on any of the data in the database. But we have certain reports that are built in, and we have both printable reports, which kind of come up initially within the GMoor environment, but you can export those to PDF, or they're designed to be printable. And we've also got Excel reports, and each report is designed to be either one or the other, and they can serve different purposes. So obviously a print report would be great as an appendix in a report, or something that you can easily refer to on paper. Excel reports are particularly good if you've got large volumes of data or things that involve very wide tables that perhaps wouldn't appear very well on a printable page. So just to sort of show a couple of examples, if I click on detailed output report, I get a box here that's very, very similar to what we saw before in the managed database. So I could, for example, drill down and say, well, okay, I want just a report on line 1 failure from 0 degrees. And if I press OK there, I get a report with a single page that refers specifically to that environmental case and line failure. On the other hand, I can rerun that, and if I click on the spread, it will implicitly report on not just that spread, but all the configurations underneath it, all of the results underneath that. So if I press OK there, it'll take a little bit longer now. You can see it's having to create the content of the report. And then now we've got a much, much longer report here where we produce that information for every single one of those results. And so, for example, in this report, for each result, we can see the line failure and the weather direction. We get a summary of our weather. We get the summary of the forcing, vessel motions, significant and maximum, vessel position and offset, and then our line tensions down below. If I wanted to export that to PDF, I've got an option to do that here. I can also export selected tables, so not the whole report, but I can export selected tables to Excel. So if I click on that, it will come up just with the tables that are on the currently selected page, and I can tick the ones I want to export. And then I could, for example, copy the info and weather tables into an Excel spreadsheet. That might be too much information in some cases, so we've got a very similar report here called the batch detailed report. So this time if I click on the spread, we'll get a much shorter report, so I think we'll get about a dozen pages or so, 9 pages. And what we're doing here is that for each analysis type, we're pulling out just the 3 cases that had the highest tensions. So we'll get the 3 directions for intact spread that resulted in the highest line tension. So we should have 3 pages for no failure, i.e. intact. 1, 2, 3. Then we'll come on to single line failure, non-transient, 1, okay, we're actually interspersing, so we'll go single line failure, transient, single line failure, transient, but we'll get 3 of each. So it pulls out just the 3 worst cases for both. So that's particularly good if you don't want to go through a whole lot of reporting and pull out every last detail yourself. Under Excel reports then, if we have a look under here, for example, if we want to see minimum maximum tensions, I can click on this one. Some of the reports will have options as well. So for example, for this report here, we've got a choice as to whether we group by line. So this will then show us for each line the minimum and maximum tension that occurred in that line, and then for which result that was found. Or we can group by configuration, and in this case our configuration corresponds to a direction. So we'll show it by line. Now because this is an Excel report, the first thing I'm required to do then is give it a name for the file, so that it'll open it in Excel afterwards. So test.xlsx. And then, there we have our table. So we've got for intact, for SLF and for transient, we've got our minimum tensions for each line for that particular type of analysis case. And then we can also see the database ID for the result in which that occurred. So if, for example, you then want to refer back from this to the more detailed output of the print reports, it's a good way of just drilling down to particular cases of interest. And as before, for example, let's just find the one here with the highest tension. So let's say here, for example, we've got the highest tension was in 184, which was line 5. We've still got the option to come into Manage Database, and then we can sort of drill into these different cases to find 184. Make interactive, and then we can sort of see the details of all of the lines. So it makes it really easy to find individual results from the reporting, and then actually if you want to sort of drill into exactly what's going on, you can take that same case, make it interactive, and then from there you can do further investigation. And then as before, if I decide I want to go back, I can just undo previous, and I'm back to my previous sort of intact case without any weather applied. We looked earlier on at one of the plots, but let's just have a look at that again. In fact, we've stored it open down here, continuing line 1. So with any of the plots, I can hold the cursor over the line and drag it along, and I can see what line component that's on and what the coordinates are for the point underneath the cursor. If I go to, just close that. If we go to this option up here, so having clicked on the plot, we get this new little tab at the top that refers specifically to that plot. So I've got options there to copy the graph to the clipboard, and I can copy it as shown, so that means it'll appear on the clipboard in exactly the resolution and scale as it's currently displayed on screen. Or I can choose to copy it to the clipboard with a particular resolution, and that could be useful if you're creating a Word report, for example, and you want to paste things in with a consistent sizing. You can use this to make sure that your plots are always in the same scale. I can also choose to export the coordinates to Excel, so that will create me a CSV file with X and Y coordinates for each of the catenaries in the plot. If I've zoomed in with the mouse, for example, and lost my scaling, I've got an option to reset the plot view back to the default. And then we've also got some other graphs we've not looked at yet. So I can click on one of the lines and do a catenary plot that way. And when I create a catenary plot via this, I will automatically generate a catenary plot with tensions that correspond to the current minimum, mean and maximum tensions. I've also got a button at the top here for catenary plot. If I click on that, I then can pick which mooring line I want to produce the plot for. I can either do tensions using the existing tensions, in which case it's the same as we just discussed, we'd get minimum, mean and maximum, or I can ask for user-defined tensions. So for example, 100, 200 and 300 tons. And then we'll get a plot with those tensions accordingly. Now, bearing in mind with GMoor, when we're referring to a particular tension, we're fixing the payout and we're specifying the tension, and so the range will vary. And so that's why in the top right we can see that the fair lead position is adjusting a little bit in each case, because what we're really representing is a fixed anchor, and then the vessel as a whole is moving to then generate either 100 tons, 200 tons or 300 tons. And so that's why we can see our fair lead position moves there in the top right. We also have a line excursion plot we can produce, where again we can select which mooring line we want to show that for, and then that will show for a differing range between anchor and fair lead what tension we would see at fair lead, both total tension and the V stands for vertical, and likewise at the anchor. And as with the other plots, we've got options to copy to clipboard, export, reset. And we've got an option here for the vessel excursion plot. So that allows us to specify a load direction. We specify a maximum load. And what we're plotting here is we're saying, well, okay, with that load applied from that direction, and we gradually scale up the load from 0 up to the 500 tons that we specified, what will be the vessel excursion along that axis? And then for each excursion that we've encountered along that axis, what will be the corresponding line tension in some of the lines whose axes are most closely aligned with that of the vessel, of the load applied to the vessel. So just going back to batch cases, there are another couple of ways in which we can automate incorporation of environmental parameters into our batch without having to type in all the cases by hand. So in the example we looked at earlier on, we were able to automatically vary the heading of the weather, but the magnitude, that was kind of fixed at gale force Beaufort scale. So there are two other options we're going to look at now for batch. One here is what's called data batch. So this is a way of bringing data in either from a CSV or an Excel file, and then for each column in that data we map each column to a property on the inputs, and then we generate then a batch case for each row in the data. So if we look at a file that I've prepared already, here we have an Excel spreadsheet, because we can load data directly from an XLSX file, though it has to be the first sheet in the file. We've got a number of columns here, so we've got columns titled description, run no failure case, run single line failure case, C direction, C period, and C height. So these will be mapped to different properties within our batch, and then these represent the individual batch cases that we're going to generate. So the obvious question might be, well, how would I know to title these columns in this particular way? And if I bring up the help in GMoor, and we come down to where we have the information on data batch, we will find here a list of these. So if you title your column using any of these properties, it will automatically map. What we're going to do here, in fact, is just change one of those so it doesn't map, and then you can see how that would work. So if we just accidentally misspell description, and I'll save that. Now it's important if you're using an Excel file to close the Excel file, because Excel will lock the file otherwise so that you can't actually open it within GMoor. So I'll close that down. I can then come into my data batch. I can browse for my data batch sample, and you can see then that it's brought in. It will only show us up to the first 5 rows of the data, but you can see that most of these headings have been mapped successfully. The unit selection, where units apply, will be based on your current preferences, but you can change those if they don't actually correspond to what the data represents. But in this case, because I'd misspelt description, I then have a drop-down box where I can pick the mapping I want to use. And again, this list is the same as the list I just showed you in the documentation, so that again, if you forget the title of a particular heading, you can use this as a reference. So if I now pick description there and press OK, you can see now we've generated then our batch cases based on that data. And because this is now brought into the manual batch facility, as before, I can sort of select things, and if I decide that there are certain options that we're missing, I can then apply those. It's just a way of getting a starting point without manually typing all of this data into the batch editor. And so if I press run batch now, that'll just go off and produce those. And we can then see under our managed database, if I do it by spread, you can see now we've got our original set from earlier, and now we've got our more recent ones from our data batch. And if I group by run date, we can see again we've got 2 distinct batches that we've run, one earlier on and one just now. And so let's just take advantage of the batch editor here, we'll delete those off, we don't need those. So the other technique for assisting with batch cases, though it can also be used interactively, are the environment tables, and this will be a new feature also for GMoor 9 users. So the idea of this is a way of pre-specifying that there are certain magnitudes of environment that vary according to the direction. So it might correspond, for example, to a 1 or 10 or 100 year return from a particular heading. And we can have multiple environment tables in the same database. So you can in one database have 1, 10 and 100 year return, or you could have 1 or 10 year returns for different locations. It's up to you how you use it. So within here I'm going to create a new environment table, which I'm just going to call 1 year return. And then I can specify a number of directions, and then for each of those directions I can specify what are going to be the 1 year return values for that direction. GMoor then, when I tell it to use the environment table, will do a lookup on the entry that is closest to the direction I've given. So there's no interpolation involved. If you want data to be interpolated, you need to sort of do that before you input the data into GMoor. So just for the speed of entry, I'm just going to do every 45 degrees here. We'll just do wind speed for the purposes of this demo, so I'm just going to vary that between 20 and 30 meters per second. Okay, but of course I can go along and I can do the same for wind. I can do it for sea height and period, swell height and period, current speed, and we can also apply extra damping based on the sea direction. So for wind, sea and swell and current, the direction that the lookup is performed on will be based on the direction we provide for each of those. So wind direction for wind, sea direction for sea, and so forth. If we choose to use the environment tables with linear damping, then that will use specifically the sea direction. So having set up my environment table, if I come into environment here, and for example go to my wind tab, because that's the one we've created the properties for, at the bottom of each of these we've got a thing that says use env table. So that's there on wind, and it's there on wave, swell and current. And if I underneath this pick 1 year return, at the moment my wind speed is variable, so I can come in here and I can type something in. If I come and say use environment table and pick 1 year return, that's set to 20 and it's greyed out, so I can't change the value. But if I was to come under here as to wind direction and change that to 45, you can see as soon as I change that to 25 degrees, that's now showing me 25 meters per second as per my table. And if I put in 90, it'll go to 30 and so forth. And it will always pick the closest. So for example, if I say 110, we're still at 30. If I go to 120, we're now down to the 25 because it swapped to the 135 degree heading. If I press OK on that, we can see down in the bottom 120 degrees, 25 meters. And then just to change it quickly, if we put in then say now 0 degrees, we can see that's dropped down to 20 meters per second in the bottom corner there. So it's just a way of meaning that all I have to do now is specify the environmental direction. I don't have to worry about the magnitude, and that carries through to batch. So if I come into batch reporting and I do a manual batch, we'll just do intact only, that's fine. We'll click on that and we'll rotate, and we'll do it every 45 degrees. So even just by doing that and rotating it, we can see here we're specifying the direction each time. If I run my batch, and then if we do the detailed output report, so we can see here from 0 degrees we've got 20 meters per second. But if I come through to the next page here, we've got 25 meters per second from 45, 30 meters per second from 90, and so on. So again, whether it's interactively or whether it's via the batch, we're automatically applying the weather we've asked for. And then just to finish off, we're not going to look in detail at the scripting, but just to explain that the scripting exists, both for creating of batch cases and also for the writing of reports. We're going to look at manual batch because we can actually kind of use the manual batch facility as a way to generate a base script. So if, for example, I come into here and I come into environment, and let's just do as we did a second ago where we were playing with the wind heading. So let's just say I changed the wind direction, so we're going to put in there 22.5, for example. So you can see down here now we've now got a batch case with a wind direction specified at 22.5 degrees, and there's a button down here we've not looked at previously that says convert to script. So if I click that, batch case will be converted into a script. So I'm going to go quite quickly over this because this might not interest everybody viewing this video, but down here we can see there are 2 lines of code that correspond to the wind speed and direction. So we can see the wind direction was set to 22.5, and the wind speed was picked up from an environment table. Well, we're not really worried about that. But I can now start coding. So for example, if I want to actually do a loop over a range of headings, I can do something like for heading equals 0, heading less than 360, we'll increment by 22.5. Rather than having a description that says copy of interactive, we can perhaps say wind from, and then we'll put in our heading. And then here where we've got our heading hard-coded as 22.5, again we can refer to heading. And one thing you'll notice is I'm typing here, if I sort of type, for example, config dot, you get a list of all the options that come up, and we've got full documentation in the help for both the database and the scripting API, but it's made easier by the fact that as I type here, if I go, for example, C dot, again we get, for example, period, spectrum, and if I look at spectrum, again we can see what spectra are available. So there's a lot less need to refer to the documentation than one might expect for script writing. But I've now got a little script here where we're going to create copies of the interactive configuration and spread. It's going to determine the possible failure cases, though we're filtering those just to the intact ones, just so our script runs a bit faster. We're going to assign a description to our configuration that is based on the heading. We're going to assign the wind direction based on the heading, and bearing in mind we're using environment tables so that the speed will then pull through as well. We're going to then run our analysis, and we're going to write those results to the database. And please remember at all times, whether it's via scripting, whether it's via batch, and whether it's interactively, when we write results to the database, we're only writing results to the database in memory. And if we want that to be saved, we need to go to File and Save. GMoor will prompt you when you close the program if you haven't saved, but please get into the habit of doing that, just like you would do with a Word document, with an Excel file, etc. It's exactly the same principle. So, and we'll just call this script every 22.5 deg. So you can see now, we've now on the scripted batch menu, we've now got a little button that says every 22.5 degrees. So I'm going to come into interactive and just delete our existing batch cases just so we don't get any confusion. And now if I click on this, it will process those cases. So it'll be really quite quick just because we're only doing the intact cases, we're not looking at line failures. And if I come now into our managed database, you can see then we've got wind from 0, wind from 22.5 and so forth. So we were able to script the behavior and then run an analysis and write it to the database all from our scripting. And again, I can say make interactive there. That's our 0 case, 20 meters per second. But if I come into here and pick our 90, make interactive, and you can see here that's 90 degrees, 30 meters per second. So again, all of our environment tables and everything is pulling through, and all we had to do with our script was just change the wind direction on its own. And the scripting can be used for all sorts of things. We can even write scripting to, for example, modify the interactive. We'll create a new script actually. So if we just call this, I don't know, fail line 1, it's maybe not the most probable reason to use scripting, but I can refer to interactive spread and interactive config. So I can, for example, say line 1, we're going to our deployments because we're deploying at each fair lead. So a line at a fair lead is referred to in GMoor as a deployment. We'll find the single deployment with a line index is line index 1, so that corresponds to fair lead 1. And we'll say line 1.status is going to be broken. So we've now got a little button there that says fail line 1. So you can see at the moment line 1 is most definitely not failed. We've got 117 tons. But if I click fail line 1, and that's now broken, 0 tons. And so you can use scripts to do quite complex things. You can save the script in the database, but you can also save the script at a system level so that you can use it with every spread file you open. And this sort of use of it interactively could be used to optimize for certain things. For example, if you wanted to try and arrive at a specific percent critical damping, you could use it to apply a particular code, particular spectra, if you've got certain standard things you always work to with all of your spreads. There are quite a lot of possibilities. There's documentation and a few examples provided. We will shortly be launching a new website for software with a blog where we're going to start sharing scripts that you might find useful. And of course, we are available for consultancy work here at Global Maritime if you think that you could do with a hand in writing some of these scripts. So that is everything for the video that we wanted to show you today. If you have any questions on GMoor, either as an existing customer or someone who has seen this video and is interested in procuring a lease of GMoor, please contact us at support@globalmaritime.com. And thank you very much for watching.